Welcome everybody. This is Alberto Marquez in the fourth video on the series for queuing theory, and we are going to discuss specifically the MG1 model. The MG1 model is a case when the time between arrivals is exponential and the service time is any distribution which has the characteristics that we are familiar with the mean service time and the standard deviation of the service time. Of course, like any other queuing model, mu represents the arrival rate, but the standard deviation is not the standard deviation of the arrival rate, it's the standard deviation of the service time. So we need to be careful while we're doing our computations. We use the same rules for Little's law to compute the total amount of clients in the queue and clients in the system as a function of the number of the amount of time waiting in the queue and the amount of time waiting in the system. And fortunately there is a closed form solution for that, and that is the expression that we have for WQ in this formula sheet. While we are not going to solve a particular problem, we will see the implication of the changes in the standard deviation or variance of the service time. Here we have an MG1 model in which the lambda arrival rate is 4 and mu, the service rate, is 6. And in the horizontal axis of this graph, what we have represented is the standard deviation of the service time. And you can see the values computed here fluctuate from 0.05 to 0.25. As a reference, if this was an MM1, the value we would be using would be 0.166. Almost there in the middle of the graph. So you can see that depending on the standard deviation or the variation of the service times, if that variation is reduced, we can reduce both waiting times and the number of clients in the system, and as well if for some reason that variation, the standard deviation or the variance increases, then we will see an increment in both waiting time and the number of clients in the system. So this is an important result, and it's a short video. I hope you find it interesting.